So, good afternoon, everyone. Welcome to the week 4 of the live session on design of steel structures. I'm your TA, Danish Bashir from IIT Madras. So, in last couple of weeks, we were seeing the different concepts on design of steel structures. In the first initial lectures, we saw the introductory lectures on steel structures, and then we saw the loads coming on our structure and the design of wind loads as well, calculation of wind loads, in fact. After that, we move to some simple connections wherein I showed you different types of the joints that we have in our steel structures. And after that, simple connections, we went to the topic of fasteners, where we, in the last week, I guess, we studied about the riveted connections, and we also saw a design problem on the design of a joint, riveted joint. Okay, so I guess it was a butt joint in the last class. So I am continuing from the same topic where I have left on the last Saturday. So in today's class, we will be seeing on the bolted connections. I hope I'm audible to you. Can anyone confirm from you? Hello? Yeah, okay, okay, thank you. Someone has raised the hand. You have any question? Okay, let me continue then. So bolted connections are similar to that of riveted connections. In rivets, we saw how a rivet is being manufactured, and then how we drive that rivet within our plates that are to be, or members that are to be connected. And if it is in the case of a butt joint, we may use a cover plate in that as well. So rivet has a head on one side, and after driving that rivet into our members, we hammer that rivet on the other side, and we form the head on the other side of the rivet as well. Similar to rivets, we have now bolts. So what is the classical definition of a bolt? uh, we can define a bolt as a metal pin which has a head at one end and shank threaded at the other end to receive the nut. So unlike the rivet, we had a shank that was unthreaded, so there were no threads on the shank in rivet. But in case of this bolt, like in bolt, we have threads like this. We have threads on the whole shank. I hope you remember from the last class we called this as shank and upper part as head. Okay, so for this shank portion, we have threads in our bolt, and on this threaded side, we just plug in one nut from this side so that we can fasten it. Okay. And apart from these two components, that is the bolt and the nut, sometimes we provide steel washers as well under the nut to serve with two purposes. So these washers are actually given because they have two purposes. First purpose is to distribute the clamping pressure on the bolt member. So like we have a washer, steel washer here, one steel washer, another steel here. I hope you are this one and this one. So when we apply the nut from this side, it applies a force, clamping force on this side as well, and this has to apply clamping force from this side as well. So to distribute this clamping force on the so I was telling you, like, so I was telling you to distribute the clamping pressure on the bolt and member. That is one of the uses of these washers. And second use is to prevent the threaded portion of the bolt from bearing on the connecting pieces. Okay, this is the second use of these washers. Okay, I hope you are getting the point. Then moving forward, the different components are shown here. You people can see this is the head of our bolt. Then this is the whole shank. Okay, and on this shank, you people can see the grips easily. These are the sorry, the threads made on this. Okay, then we have the nut portion. Nut here. This is one washer here. Okay, this is one washer here, and this is another washer here. Okay, this hole from one end of from the bottom side of the head to the end side of the this shank. This whole length is known as bolt length. Okay, and whatever is the distance between the two washers or the bottom of the head to the top of the nut, we call that as grip length. Okay, this is known as grip. So these bolt heads can be of different shapes, like you can see ordinary hexagonal head bolt. So this its shape is like that of a hexagon. Okay, hexagon, its shape is like this is a hexagonal bolt shape. Okay, let me draw that. It can be like this. Okay, or it can be ordinary square bolt as well. Okay, square bolt as well. These are two types of bolt head types. Okay, hexagon, and this can be square. Okay, ordinary square bolt, we call them as I will tell you what are these ordinary or what is this in coming slides. Then so what is necessary in this bolt connection is that for the proper functioning of the connection or the proper load transmission between the two members which are being connected by this bolted connection or the bolts, it is necessary that the parts must be tightly clamped between the bolt head and the nut. That is between this bolt head and between the end of the nut. These parts should be very tightly clamped. Okay, so that there is clamping action between bolt head and the nut. Okay, so there are very unlike the riveted connections, there are numerous advantages of bolted connections. Okay, numerous advantages. One of the important advantages is I will add a page here. So, like if you people see that in riveted connections, we have to make the rivet heads on the other side, but here you just have to fasten the nut on the other side. You will get a joint on the bolt joint. So the speed or the erection of the structure can be speeded up. Okay, so advantage is first advantage is less time. Okay, less time required for structure structure to erect. Okay, so it's very obvious if you take very less time in connecting different members, then there will less time will be taken for the structure to erect. Okay, and in riveted connections you need a very skilled labor that can make the rivet heads on the other side, but in bolted connections fastening a nut on the other side is very easy, so less skilled persons are required. Okay, so less skilled persons are required. This is the second advantage. These are the, I mean, say that two important advantages of using bolt connections. And the general objectives of the use of bolts are uh, uh, first is, let me write objectives here. Okay, Objectives is cost of the material is high. Okay, I have written somewhere here. Okay, yeah, general objectives here. We can see these general objectives here. Okay, so the cost of the material is high, about double that of rivets. Okay, for example, if there is some fixed price for the rivets, we got the same connection of bolts in the double price. Okay, so that is one of their. The tensile strength of the bolt is reduced because of the area reduction at the root of the thread, and also due to stress concentration. Like I told you in the bolts, like if we have shank like this is the shank. On the shank we have threads like this. Because of threading on the shank, we reduce the effective cross sectional area of the shank, because of which the tensile, I mean to say that tensile strength of the bolt is reduced because of this threading. Okay, and also because of these threads, there is stress concentration at the numerous places. Okay, so this leads to two important things. First is less cross sectional area, and it also leads to stress concentration. Okay, due to threading of the rivets. Okay, uh, normally there are of a loose fit expecting turner bolts, and hence their strength is reduced. Okay, if we see riveted connection, if we make the rivet head on one side and then hammer it on the other side and also make the head on that side, that connection will not get loosened the due course of time, because that rivet head on the other side will be permanent. So as far as it will not break due to some extra forces that will act on it. But in case of bolted connections, what happens is that if there are any undesirable vibrations in our members which are being connected by the bolts, then these nuts get loosed, which ultimately leads to the loose fit, and strength gets compromised. Okay, and that I already told you. Third and fourth point is like due to vibrations, subject to vibrations, bolts may get loose. Okay, then moving forward, we have to see what are the uses of the bolts. Okay, the first use of the bolt is bolts can be used for making end connections in tension and compression members. They have uses in both tension as well as compression members. Okay, compression member. Bolts can be also used to hold down the column bases in position. Okay, this is one of the important applications of these bolts. Like for example, if we have a column like this, we have to erect it somewhere, and it is being held by some plate or base like this. Sorry. Okay, it is being held by this plate. Okay, then we can use bolts on this. Okay, this is the bolted connection. Like this is the nut on this side, this is the head from this side, this is the nut from this side. Okay, like this, these are the bolts. Okay, column. Okay. Okay, they can be used as separators for purlins and beams in foundations, etc. This is one more use of these bolt connections. So there are several types of bolts used to connect to structural elements. Okay, as I was earlier talking about, what are the different types of the bolts? One is unfinished bolts, another is turned bolts. Then there is ribbed bolts. We got here high strength bolts and interference bolts. We will see one by one what these bolts are. Okay. So the first is unfinished bolts. These unfinished bolts are, we can also call them ordinary or common or rough bolts. They are also known as black bolts. Okay, so they have different names like ordinary bolts, common bolt, rough bolt, also known as black bolts. They can be used for actually light structures like purlins, bracings, etc. under static loads. But if there is impact load or vibrations or the fatigue structures under fatigue, these unfinished bolts are not recommended. Okay, I will write this thing for you. So first is a unfinished bolts. Unfinished bolts, they have different names. They can be also called ordinary, or we call common, black, okay, or rough bolts. Connect light members like purlins or bearings, bracings, I think. Okay, bearings and bracings. And this is whole under static loads. Okay, loads. Okay, in impact, dynamic, and fatigue loads, bolts are not recommended. Okay, bolts are not recommended. Okay, this is the brief overview of these unfinished bolts. Then we have turned bolts. Okay, actually, these are actually similar to unfinished bolts. There is a difference that the shank of these bolts is formed from hexagonal rod. Okay, these are turned bolts. We can write similar to unfinished bolts. Bolts, but difference is shank made from hexagonal rod. Okay, this is the difference there. Okay, their surface is prepared very carefully and are machined to fit in the hole. Okay, their tolerance is very small. Okay, tolerance allowed is very small. Okay, they are prepared carefully and machined to fit hole. Okay, these are not used nowadays. Okay, high shearing and bearing strength as compared to shearing and bearing resistance as compared to unfinished bolts. Okay, high shearing and bearing strength compared to unfinished bolts. Okay, this is turned bolts. Then there is one more, that is ribbed bolts. Okay, so in ribbed bolts, like unfinished bolts, these were turned bolts. Okay, so in ribbed bolts, what we have, these bolts are also called fluted bolts. Okay, it's actually, why they are called rivet bolts, because their bolt head is like a rivet head. Okay, and the threads and the nut are provided on the other side of the shaft. Okay, it is there. So I will write here, rivet bolts have Head of bolt like rivet head, and threaded from other side, threaded from other side to put nut. Okay, it is there. Then rivet bolts, we have high strength bolts. These are one of the common types of bolts that we use. Okay, high strength bolts. Okay, so if we see in the ordinary bolts, or we saw the unfinished bolts, the force is transmitted through the interlocking and bearing of bolts. But in high strength bolts, in addition to this interlocking and bearing, there is one more factor which accomplishes the force transmission. That is through the friction between the interfaces formed between the load carrying elements. Okay, this friction is applied by applying a load normal to the joint by tightening these bolts to the proof load. Okay, so that's why we tighten these bolts very too much up to the proof load, so that they develop a friction between the so that a friction is developed between the interfaces that are being connected. Okay, that is the difference between ordinary bolts and high strength bolts. So I will write here. So apart from interlocking and bearing, interlocking and bearing force between members is transmitted is transmitted due to friction between the connecting interfaces. They are tightened very they are tightened very highly. They are tightened very highly up to proof load. Okay, because of which normal force is developed which leads to friction between interfaces. Okay, this is the basic definition of these high strength bolts. Okay, then moving forward, we have what are the advantages of there is one more uh, so because of this they develop a friction because they develop a grip because of this friction, so we call this as high strength friction grip bolts. Okay, okay, we can write Grip is developed due to friction. High strength friction grip bolts. Okay, so there was a figure I had attached it in my PPT. Okay, like here we can see this high strength bolt, how it, what is the principle of working. Okay, so like this is the tensile force P and P acting on this, and this is the tension force within the shank T. Okay, okay, like if we have steel washer here, because of this tension, there is a very high tension that is uh, being created because of tightening this high strength friction grip bolts to up to the proof load, because of which a very interfacial friction is created, F shown by here. Okay, F and F shown by here. So this is how a high strength friction grip bolts works. Okay, I wanted to show you, you people will see how this tension is being created. So like this, if you see that, like let me draw this very clearly here. Okay, to give you a full picture of what actually is happening in high strength friction grip bolts. So like if we add a blank page here, so like if I have one, like this is washer here, this is another washer here. Okay, I will add a bolt here. Okay, this is, I added one bolt here. I added one more bolt here. Okay, so for example, if they were, so there was a member like this, force was being transmitted between these two members, like it was from this side. Okay, 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 like this is like this. Okay, so what happens is, for example, this is the pull P that's acting on this member from this side P. This is a pull acting on this member from this side P. And obviously we have these bolt heads here. I forgot to make them, but the bolt heads at the top and the bottom. So we have like, this is bolt head. Like this is a little bit rounded, and we have like this, like this. This is the bolt head. This is the bolt head like this. Okay. From this side we have shank. Okay. and on this we have a nut like this. Okay, this is nut. Okay, so we saw that what is happening in it is we are seeing that a tension is being created in this board like this T, because you know that we are tightening this up to the proof load. So a tension is being created into this. Because of this tension, there is a one interfacial friction F being created here. Okay, F from this side and F from this side as well. There is one more friction being created here. Here is the interface between the washer and the nut. So it is being created like this, and another from this side. Okay, this is F and F being created from these two sides. Okay, uh, so it is like this and P. So what we see that is how this tension is related. So if we see this frictional force F will be obviously equal to, it will be equal to coefficient of friction mu between the interfaces times the normal force, and normal force is T here. Normal to this surface frictional force is T here. Okay, so it will be times T. So F is equal to mu times T. This is the for high strength friction grip bolts. Okay, this is like this. So how to design this design of high strength friction grip bolts? So for example, I will write here design. How we do this? Its design is, for example, we had only two interfaces here. One interface here was here one, and this was second interface. So for example, we had n interfaces like the same. Then we have n times friction will be created n times. Okay. Okay. So for example, we have n interfaces. Okay. We have n interfaces. So and T is obviously proof load. So and also we use a factor of safety Fs. Okay, factor of safety. So it has different values, like I will tell 1.4 for all loads except wind. Okay, and 1.2 for wind loads. Okay, wind load. So total frictional force F that will be created will be number of interfaces n times the coefficient of friction mu times the proof load T divided by the factor of safety Fs. So this is how we design high strength friction bolts. Okay. So if the diameter of the bolt is assumed and proof load is taken from the code, then the frictional force can be computed. Okay, so like how you design this? So T, like T from code, code, and it's calculated. If we assume diameter of bolt, we can calculate F. Okay, that is how we determine the friction strength of strength of the high strength friction grip bolts. Okay, because so we also call them high strength friction grip. Okay, HSFG. Okay, so there are a lot of advantages of using this high strength friction grip bolts. Okay, so as there is a lot of friction between different interfaces, they make the joint very rigid. Okay, advantage of high strength friction grip bolts. Okay, okay, HF. Okay, first is the very rigid joint. Okay, and you know the reason why the joint is rigid because of the friction between the interfaces. And second is as we fasten these bolts to very high tensile forces, which in turn provide large clamping force for the elements to be connected. High friction resistance is developed, providing the high static strength of the joint. Okay, so large tensile stresses are developed. Stresses developed, which leads to increase in clamping force, which leads to increase in friction, and this increase in friction leads to the increase in static strength of joint. This is the second advantage. Okay, third, so because clamping action is there, clamping action is there, so load transferred, load transferred or transmitted in high strength friction grip bolts, HSFG, is through friction only. So because of this, bolts are not subjected subjected to shear and bearing. Okay, shear or bearing. Okay, that's one more advantage. If you see that the load is mainly transferred through that frictional action between different interfaces, so there is a very less chance of force being transmitted through the net section or the through the I mean to say that whatever we make the holes in our plates and the members, and wherever there is the critical section, then we calculate the net section at that point. So that becomes ineffective there in case of high strength friction grip bolts because forces are transferred through the interfacial friction. So because of which the failure of the joint at the net section becomes minimum. Okay, that is fourth is failure of joint at net section minimize it. Okay, so it is there. Fifth is so as the force is being transferred through friction, so there is no stress concentration on holes. Okay, on bolt holes. Okay, and the tension is uniform. Six will be tension in bolts is uniform. Tension uniform. Okay, we can see a lot of advantages of high strength friction grip bolts from the book itself. So I will move forward. So this was regarding the all regarding the And this was everything we can study in these bolted connections. Okay, so moving forward, we can see the different things in other connections, like we have welded connections, simple welded connections. We'll see a basic introduction on that, and then we will stop the today's class. So, what are simple connections that are or welded connections? So, the definition is basic definition is when two structural members are joined by means of welds, the connection is called a welded connection. Okay, so that's why these welded connections were used extensively in the last few decades because designers think that these welded connections are less fatigue resistant and have a very good quality welded connection. Like these have been used extensively. Okay. So there are a number of reasons for using welded design, but few basic ones are here. Welded design offer opportunity to achieve a more efficient use of material. Okay, welding is the only process that produces one piece construction. Okay, so like using welding only, we can achieve a joint connection like that. If there is no joint and a member is a single member, if we are connecting two members, so this welding gives the feeling like that. Okay. And one more important use of this welding is that the speed of fabrication and the erection help us compress production schedules. Okay, it is there. So, what are the different types of the welds is in the figure I have shown. So, for example, we have two basic types of welds. Let me write here types of welds. One is fillet weld. Okay, fillet weld. Okay, one is butt weld. Okay, butt weld. So, for example, if we have one plate like this and we want to attach one more plate on this like this, for example, we want to attach this circular plate, then we will fill this interface here with weld. We call this as fillet weld. It is filling some space here between the two interfaces. And butt weld, if we have one plate like this and we want to join another plate like this with it, we will fill it with a weld like this. We will do welding like this. This is known as butt welding. Okay, or butt weld. This is known as fillet weld. Okay, so I can show you the same in the figure here as well. So we are connecting two members, like one member is here like this, one member is here like this, and we are filling this with a corner weld. So fully filling it with this. So we will call this as corner butt weld. Okay, and we or horizontal butt weld can be when two are joined like this. Okay, I told you, for example, I have to join this member with the bottom plate, so I have to fill like this on sides of this member like this. We called it as uh, T flat weld because it makes the shape of a T. Okay, we called it as flat weld from this side as well. Or there can be like this makes a slot like here, no, we called it as slot weld. and it is a flat weld type of flat weld itself, but we are doing it in within a slot. It is known as flat slot weld. Okay. For example, this is whole member like I showed you earlier. This is another member. We are filling it with something full weld that is known as flat butt weld. Okay, that is there. Uh, So what are the different weld shapes? It can be square, it can be single V, okay, like only single V. It can be double V like this, okay, or it can be U type. These are all types of welds, okay. But in fact, the types of butt welds, okay, because we are joining U, or it can be W, okay. And then moving forward, we have types of this fillet weld also. Like I told you, we fill the weld on one side like this. So if this surface is in convex shape, we call it as convex fillet weld. Or if this shape is in concave shape, we call it as concave fillet weld. Or if it is like flat, no convex, no concave, we called it as mitri weld. Okay, convex, concave, and this. Okay, so then there is, I showed you these two things. And moving forward, this is the types of fillet weld. Okay, then mm, we have another topic is welding process. How this welding is done. I think that is not the important so far. This design of steel structures is considered. Let me tell you the common type of welding process used as metal arc welding. What we do in this metal arc welding is that this metal is melted on the joint, and both are melted to that degree that the metal between the two elements will bond with each other, and when it is cooled, it will form a strong bond. Okay, like we have base metal, connecting metal, then we use arc stream and put it on that, and molten pool is there. I think that's not important welding process. We have one of the important things is the welding defects. Okay, what are the weld defects? There are numerous welding defects as I have shown here in the figure. Is like, for example, if we do fillet weld and there is a lack of connection between the member and the weld, that is the lack of fusion between the connecting member and that weld that is made there. This is known as lack of fusion. It can be in the fillet weld, it can be in the butt weld as well. So if butt weld was here like this, so it is not completely fused with the connecting member or the member to be connected, so we call it as a lack of fusion. Okay, okay, or we call it as incomplete fusion as well. It is the failure of the base metal to get completely fused with the weld metal. Okay, we can write here base metal not fused with weld metal. Okay, that is there. Then there is incomplete penetration. Okay, this is one of defect in welded connection. Is like both in fillet weld as well as butt weld. Like if we put a welding metal on that, it has not completely penetrated the gap. Like in there is a cavity created here. There is a cavity created here. Okay, so it is the failure of the melt metal to penetrate the complete depth of the joint. Okay, it is normally found with a single V and bevel joints, and also because of the large size electrodes. So if we are using large size electrodes for welding, so it will create incomplete penetration in both flat weld as well as butt weld. So in incomplete penetration, so what is there? Weld metal and doesn't penetrate completely into joint, okay, and it is caused by large electrodes. Then there is one more, gas pocket, okay. We also call it as porosity, occurs due to the voids of the gas pockets and trapped in the weld while cooling, okay. It can happen in butt weld as well as, sorry, butt weld as well as fillet weld as well. So what happens is that gas pockets created, okay, created. It actually leads to stress concentration because of mm, income porosity, and also reduce ductility ductility of joint, okay. There is one more, slag inclusions. These are actually the metal oxides and other solid compounds which are sometimes found as elongated or globular inclusions, okay. This is there, okay, slag inclusions, okay. So in slag inclusion, metal oxides or other solid compounds get included in the weld. Okay. Then there can be, this is slag inclusion is one more. This is undercut. Okay. It's not with this actually. Sorry. This is a defect, slag inclusion. Metal oxide. Okay. Then there can be cracks developed in the weld. Okay. It is there. There is undercutting. It is a local decrease of the thickness of the parent metal at the weld toe. Okay, this is caused by the use of excessive current and very long arc. Okay, so like what undercutting means that at the toe of the weld, like the toe is here, and toe is here, toe is here. So because of the very high current, the base metal gets melted. That is known as undercutting. Okay, I can write it as undercutting as local decrease of base metal, okay, base metal or parent metal at the weld toe, at the weld toe, okay. It is caused by excessive current, okay. Okay, these are the important, I mean to say that defects welding, defects both butt weld as well as felt weld, okay. Then we have stresses in the welds. What are the permissible stresses? So the first stress is tension or compression on the section through the throat of the butt weld. This is 150 Newton per mm square. Bending stress in either tension or compression. The permissible stress is given by the code is 165 megapascal. These are taken the values from IS 226. Okay, actually these are IS Indian Standard 226 1975. Okay, 1975, and these are for the electrodes conforming to IS 814, okay, 2004. This is for electrodes, okay. Or we have shear on the section through throat of butt or flat weld, it is 108 megapascal, and for plug weld its permissible stress is 108 megapascal. So the important point is there, if welding done in field, we have to reduce 80 we have to reduce stresses in shear or tension by 80%, okay. This is one important point there. Or if effects of effect of wind load or earthquake load is considered, We have to increase the stresses, permissible stresses, increase permissible stresses by 25%. These were the two important points that I want to mention here. So then there is one more important topic is design of butt weld. I think we can do this design of flat weld as well as design of butt weld in the next class, and we will solve a numerical problem regarding this on the second class as well. So welding will be completed on the second class, next class as well, and in the next class we will take on compression members also. Okay, thank you everyone for joining the session.